Hello students, welcome to the subject of complex variable and partial differential equation. This is Dr. Ankit Acharya, and as you all know that in last lecture we just completed our first case for particular integral, and first case is f of xy that is equal to e raised to ax plus by. Now this is totally different case. This is case 2. In case 2, what is your function? Function is nothing but sine ax plus by or cos ax plus by. Okay, for sine function or cos function. For both the function, we have to apply the same rule. And what is the rule? Let me explain. So, particular integral, you can see on your screen that particular integral is nothing but 1 upon f of d square, okay, d into d dash, right? 1 upon f of d square, d into d dash square, sine ax plus by, okay. Instead of d square, you have to take minus a square, okay, minus a square, okay. So suppose a is equal to 2, so 2 square is what? 4, and take minus sign. So instead of d square, that you have to take minus 4, okay. Now similarly, instead of d into d dash, you have to take minus ab, right? Instead of d into d dash, you have to take minus ab, and instead of d dash square, you have to take minus b square. So this is the rule. Whenever your function f of xy that is equal to sine ax plus by or cos ax plus by, you have to apply this important rule, nothing else, okay. That means what? Just you have to take the values of d square, d into d dash and d dash square. You cannot take the value of d and d dash, right? Okay, make sure instead of d square, d into d dash and d dash square, only you can take these values, okay. Instead of d square, you have to take minus a square. Instead of d into d dash, you have to take minus ab, and instead of d dash square, you have to take minus b square, okay, as I explained here. Right now you can understand. Say rule is same for both the function, either sin ax plus by or cos ax plus by. I just mentioned here the above rule is also applied for cos ax plus by with the same method, right? Now again, suppose denominator becomes 0. So as you all know that same rule we have to apply, which we apply in case 1. You have to multiply with x, okay, you have to multiply with x, differentiate of f of d dash with respect to d, okay, and apply the same rule once again, right? So that's why I write here, suppose f of minus a square minus ab minus b square that is equal to 0. So then apply this rule, multiply with x, 1 upon f dash, so this is f dash, okay, minus a square minus ab minus b square sine ax plus by, okay. So I hope you can understand this rule. Let's solve some of the examples. So this is my first example. As you all know that in each and every example, first you have to find out the complementary function. So f of d dash here, that is equal to what? D square minus 2d dash, right? So minus 2d dash plus d dash square, that is equal to 0, okay. So the function of m, that is m square minus 2m plus 1, that is equal to 0. So that's why m minus 1 whole square, that is equal to 0. Don't forget to write what is your m. M is nothing but d by d dash, okay. Basically you are dividing this equation with d dash square because this is homogeneous function, so that's why you can do it, okay. So roots are 1 and 1 1, roots are 1 1, okay, repeated roots. So that's why complementary function, that is equal to f1 y plus x plus x f2 y plus x, okay. Now I want to find particular integral. So particular integral that is equal to 1 upon f of d dash, so 1 upon d square minus 2 d dash plus d dash square sin x, okay. So this is my particular integral. Now I write this particular integral once again on the next page. The particular integral is, so you can easily understand, particular integral that is equal to 1 upon d square minus d dash plus d dash square into sin x, okay, minus 2d dash. So here we have to take minus 2 d dash plus d dash square. Now compare this function sin x with sin ax plus by. Compare this function with sin ax plus by. So what is your a? First of all, a is equal to 1, and what is your b? B is equal to 0. Clear? Now instead of b square, right, we have to take minus a square. So minus 1. Instead of d into d dash, we have to take minus ab. Okay. Instead of b square, don't forget, instead of b square, we have to take minus a square. So that's why I have to take minus 1. Instead of d into d dash, I have to take minus ab. So that's why I have to take 0, because this is minus 1 into 0. That will become 0. Instead of d dash square, I have to take minus b square. Okay. And what is my b? B is nothing but 0. So that's why minus 0 square. So that's why 0. So now you can understand that instead of d square, I have to take minus 1. Instead of d into d dash, I have to take 0. Instead of d dash square, I have to take again 0. So that's why particular integral is, now you can easily understand. First of all, instead of d square, I have to take minus 1. So this is minus 1. Then minus 2. D into d dash 0 plus d dash square. So that is 0 into sin x. So what is my final answer? Particular integral is minus sin x. And now each and every example, I don't write the general solution. General solution you can easily write down. Z is nothing but complementary function plus particular integral, but you have to write down in your examination. So what is my final answer? Complementary function. General solution is nothing but cf plus py. So z is equal to f1 y plus x plus f2 y plus x plus minus sin x. Okay, so this is my general solution. Now next example. D square minus 2 d dash into z, that is equal to sin x into cos 2y. So first of all, this multiplication form, that you have to convert into addition form using the formula that we know that 2 sin alpha into cos beta, that is equal to sin alpha plus beta plus sin alpha minus beta. Okay. So using that formula, first of all, you have to multiply this function with 2, right? So this is nothing but 2 sin x into cos 2y and divided by 2. So divided by 2. So 1 by 2. So that's why this equal to, I can write this function is nothing but 1 by 2, right? 1 by 2 into 2 sin x into cos 2y. So sin x plus 2y plus sin x minus 2y. Okay. We apply this formula, that 2 sin alpha cos beta, that is equal to sin alpha plus beta plus sin alpha minus beta. Okay. Now, first of all, we find complementary function. So that's why, what is my f of d dash? F of d dash, that is equal to d square minus 2d dash, that is equal to 0. So that's why m square minus 2m, that is equal to 0. So m will be common. Okay, m minus 2, that is equal to 0. So what are the roots? Roots are nothing but 0 and 2. Okay, the roots are nothing but 0 and 2. So complementary function, that is equal to f1 y plus 0 into x. Okay, so that is f1 y plus f2 y plus 2x. Okay, so this is my complementary function. Now, what is my particular integral? Particular integral is nothing but 1 upon d square minus 2d dash. So now, what is my particular integral? Particular integral, that is equal to 1 upon d square minus 2d dash. Okay, what is your f of d dash? Let me show you, right? 2d dash. So what, d square minus 2d dash. 1 by 2 is already there, right? So 1 by 2. First function is what? Sin x plus 2y. Okay. So sin x plus 2y plus 1 by 2 plus 1 by 2 1 upon d square minus 2d dash, d square minus 2d dash sin x minus 2y. Okay. Now you can understand that instead of sin x plus 2y, okay, now for sin x plus 2y, you have to apply this rule for sin x plus 2y. You have to apply this rule for d square, because for that what is your A is equal to 1 and B is equal to 2. Okay, so instead of D square you have to take minus 1, instead of D into D dash you have to take minus AB, so that is minus 2, and instead of D dash square you have to take minus B square, so that is minus 4. Okay, for sine x minus 2y. Okay, for sine x minus 2y, instead of D square, because for that A is equal to 1 and B is equal to minus 2. Okay, so for that D square, instead of D square you have to take minus 1, instead of D into D dash you have to take minus AB, right? So minus 1 into minus 2, so that is 2, and instead of D dash square you have to take minus B square, so that is minus 4. So you have to apply this rule. So that's why particular integral is now nothing but 1 by 2, 1 upon, instead of D square I have to take minus 1, so minus 1, minus 2, instead of D into D dash I have to take minus 2, so minus 2 into minus 2, sine x plus 2y. Okay, plus 1 by 2, plus 1 by 2, 1 upon, right, instead of D square I have to take minus 1, so minus 1, minus 2, right, D into D dash, instead of D into D dash I have to take 2, so that's why here I have 2 sine x plus 2y. So minus 1, now you can understand this is minus 1 plus 4. Okay, so minus 1 plus 4, that is 3 into 2, so 6. So the first term is 1 by 6 sine x plus 2y, and the second term, what is my second term? Minus 1 minus 4. Okay, so that is minus 5 into 2, minus 10. So that's why the second term is minus 1 by 10 sine x minus 2y. So this is my particular integral. Okay, and as you all know that general solution is complementary function plus particular integral, so just write down. Okay, so in today's lecture we discuss about case 2 sin ax plus by or cos ax plus by. For this type of function, how we can find particular integral. So thank you.